So hello friends, welcome again. Huh, in the first part of my video of lesson number 1, number system, I introduced all the types of numbers and told you some rules. So in this part we are going to continue number system with exercise 1.1. So the first question of exercise 1.1 is, can 0 be written as n upon d? Means 0. Here we take, sorry for the interruption, here we take 0. Can it be written as n upon d? In the question it's given p upon q, but for simple understanding I have taken it as n upon d. So can 0 be written as numerator upon denominator? Remember the rule which I told in my first video, that any number which does not have a denominator, can be written as this. We can write the denominator as 1. Let me repeat, any number which does not have a denominator, we can write the denominator as 1. So here we will write what will be the statement. Answer is here, but we also have to form the statement to get our answer true. So the statement is, yes, 0 can be written as 0 upon 1, where 0 is numerator and 1 is denominator. So this is the statement. Yes, 0 can be written as 0 upon 1, where 0 is numerator and 1 is denominator. And you will get the full marks of the question. Now let's move on to question number 2. So question number 2 is, we have to find 6 rational numbers. I hope you know now what are rational numbers. We have to find 6 rational numbers between 3 and 4. So now rational numbers are numerator upon denominator, but here we have only given numerator. So what about denominator? We right now solve the first question. So we are going to write 3 upon 4 as 3 upon 1 and 4 upon 1. So here the LCM same, so we do not need to take out the LCM. Here the denominators are same, so we do not need to take out the LCM. If suppose in the question it would have given 3 upon 2 and 4 upon 4, then we would surely have to take out the LCM. But here we have only given 3 upon 1 and 4 upon 1. So simply 1 and 1. For your simple understanding, I am showing the LCM. So 1 and 1 LCM is 1, 1. So what? 1 multiplied 10 is equals to 10. If the LCM is same as the number, as the same both numbers, then we have to multiply it by 10, and 10 is here. So we are going to multiply this also with 10. So 3 multiplied 10 upon 10 and 4 multiplied 10 upon 10. Sorry for the disturbance. Here now we are going to do it as 30 upon 10 and 40 upon 10. Sorry. So now we do not have rational numbers between 3 upon 1 and 4 upon 1, because there are only two, 3 upon 1 and 4 upon 1. But now we do have rational numbers between 30 upon 10 and 40 upon 10. we have 10 rational numbers. So our question was find 6 rational numbers. So here we will write therefore 6 rational numbers. So the 6 rational number are 32, 31 upon 10, 32 upon 10, 33 upon 10, 34 upon 10, 35 upon 10, 36 upon 10. So now, what if in the question you have been given find 20 rational numbers between 3 and 4. So here only 10 rational numbers are there. So what will you do? You will again multiply this with 10 upon 10. The answer will be 300 upon 100 and 400 upon 100. Now you have 100 rational numbers between 3 and 4. Let me tell you one more thing. There are infinite numbers between 3 and 4. Means between any two numbers there are infinitely many numbers. This is the symbol of infinite. So now let's move on to third question. So here comes the third question. Sorry for the interruption again. Question number third. We are given find 5 rational numbers. So we have to find 5 rational numbers between 3 upon 5 and 4 upon 5. So here we have already been given the denominator. So we have already given rational numbers. We have to find rational numbers between these rational numbers. So now what we will do? 3 upon 5, 4 upon 5. So here we will take out here we will take out LCM. So what will be it? 1 1 5 multiplied by 10 50. So here we are again, I'm doing it fast so the handwriting may be not much better, but you will be able to see this much clear. So now let's move on. We are again going to divide multiply this by 10 upon 10. We will again get 30 upon 50 and here 40 upon 50. So here we will again write 5 rational numbers. 31 upon 50, 32 upon 50, 33 upon 50, 34 upon 50 and 35 upon 50. So here are the 5 rational numbers. So now you would probably know how to find rational numbers between any two rational numbers. Now let's move on to question number 4 and the last question of this exercise plus the last question of today's video. So the question is true or false. Question number 4 is true or false. So now the first one is every natural number, every natural let me take the textbook for the question. Every natural number is a whole number. whole number. We will write as this. So now the textbook is asking us that whether every natural number is whole number. Textbook has given a statement that every natural numbers are whole numbers. We have to say that whether it's true or false that every natural numbers are whole numbers. So let's see. 1, 2, 3 here, 0, 1, 2, 3 and infinite. So now natural numbers start from 1 and are endless. Whole numbers start from 0 and are endless. So now 0 does not come in natural number. So we can say that all natural numbers are whole numbers. Remember the formula. N, W, Z and R. All natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers. So all natural numbers are whole numbers. Hence, it's true. Black pen is dull, I'll have to refill it. So right now I'm going to use the blue pen. Now the second one. The first one is true. Now the second one is every integer is a okay. So now we are going to write it as every integer is a whole number. So we have to say that is every integer a whole number. So first we are going to write every integers: -3, -2, -1, 0, 1, 2 and 3. Whole numbers again 0, 1, 2, 3. So now we are able to see the positive side here, but what about the negative side? And in the question it is given every integer is a whole number. Now in the statement I told that we cannot do vice versa of this, and the textbook has asked the question vice versa, that all the integers are whole numbers. So we are going to say no, all the integers are not whole numbers. So now let's move on to third and last but not least. Sorry, I took out the statement and W Z R. Second was false. Now let's come to third. So let me check. Yeah, every rational number and whole number. So we have been given rational number and whole numbers. So rational number are numerator upon denominator form -3 to okay, let's sorry for the handwriting guys, really sorry. 2 upon 4. I'm in a hurry to it, that's why. So now let's take whole numbers. So again they are going to write 0, 1, 2 and 3. So now here is minus, and every whole number we can write them as this, right? Because of 1's universal. But what about the negative side? I also told previously that all the whole numbers are on positive side, but those numbers which conclude negative sides, we cannot add them. We cannot add them into whole numbers. We can add whole numbers into them, but we cannot add them into whole numbers. Here it's vice versa question. All real numbers are not integers, just ask directly whole numbers. Rational numbers are part of real numbers, so we can say that all rational numbers are whole numbers, but that's vice versa, and vice versa is false. So this is false. Here the third one's false, right? Now if you like the previous video and this video also, please subscribe my YouTube channel and leave a like. I would hope you would enjoy studying with me. I will keep uploading new videos on new topics, new subjects. I am going to teach here from class 6 to class 9th, but currently 9th is going. After maybe one or two chapter, I am going to take class 7th. I am going to take all the classes. So please, if you want some videos, leave a comment, and if you like the video, please subscribe my YouTube channel and leave a like. So that's it for today. Thank you for watching my video, and bye.